Bedard, lead AI gameplay programmer at Ubisoft Quebec City in Canada. I'm super happy to be with you today to talk about AI improvements that we did on Assassin's Creed Syndicate. Then afterwards, share a couple of best practice accumulated over the years. So let me switch to the presentation. Here we go. So a little bit about myself, and yes, that's me on the picture. I've been studying at University of Sherbrooke in Canada in software engineering. Graduated a while ago, so you can guess my age. My first job was to start developing real-time embedded software for power lines automation controllers. Always been super passionate about AI, so I had the opportunity to join a startup, which was called Victum Human Bionics, to develop the AI of a motorized prosthetic leg named the Power Knee, which is commercialized by a company from Iceland, Osher. Then I joined the video game industry in 2005 as an AI and gameplay programmer. My first steps in the gaming industry was to work on a couple of licensed games, but my first quote-unquote AAA game on a more, let's say, known license was on Prince of Persia: Forgotten Sands, where I worked as an AI programmer. Then after Prince of Persia, I switched to the Assassin's Creed franchise, still working or being involved more or less in AI. On Revelations, I worked on the carriage driving NPC's AI. And then on Blackfly, I worked on naval systemic ingredients. Afterwards, I worked on the Freedom Cry DLC, mainly worked on the systemic events, spawning, unspawning, like small quests around the player, managing NPCs and win-lose conditions. After I briefly worked on Assassin's Creed Unity to help them with the massive crowd system. Then my biggest title and involvement so far was on the latest Assassin's Creed title in the franchise. For that, and it's going to be the main topic of that presentation, we had to overhaul the whole AI to support a huge systemic and dynamic world. So enough about me. Let's jump into the heart of the presentation, and it's going to be split into two main parts. Obviously and carefully named part 1 and part 2. So first one is about improving the NPC's navigation and pathfinding in a fully dynamic and systemic environment. And then, as I was saying, a couple of best practices I'm going to be sharing. Let's start part 1. So beforehand, I need to give you the context of where we had to work AI-wise on the AC Syndicate. The game is taking place in 1868, Victorian London, which was during the Industrial Revolution. So when we talk about Industrial Revolution, we have to say that the whole world was in motion. We had massive crowd everywhere. Pedestrians on sidewalks, park, in the streets, all over the place, because London was at that time considered like the center of the world. We also had massive carriages traffic in the streets, massive boats traffic in the Thames River, but also, at last not the least, a whole railroad network with trains having their own schedules and train stations and stuff like that. An interesting fact for us is it was the first Assassin's Creed game where we could use real photographs for our research, which helped a lot. So let's show a photograph. This is how London was looking back then. So, using archives like that as a primer for the vision, on our side on AI, we're like, okay, how we will render all this and render the vision and the fantasy in our game. What is a NPC in the Industrial Revolution? Well, The NPC needs to steer around obstacles. Some of them will have weird and arbitrary shapes. The NPC also needs to switch from ground navigation to driving a carriage and that back and forth. And to add more dynamism and excitement, we want the NPCs to jump to moving vehicles from the ground or another moving vehicles. Here's a screenshot that portrays a quite chaotic setup where you can see the player driving a fire truck with the red NPC climbing on it on the back, and you can see another red NPC standing on top of another carriage, just about to jump on the player's vehicle. And on top of that, there's the whole world life with the carriage traffic, pedestrians and stuff. So to sum up, it's quite a challenge. So how can we achieve that vision technically? We built a road network to provide an abstraction layer for the street's topology. Then we implemented a traffic manager to handle massive carriages driving in the streets in some sort of organized way. We had to rework the navigation mesh system. Then we had to rework steering engine for the NPCs, reworked the decision-making systems, and finally we virtualized the NPCs. Here you can see a screenshot in the editor with debug display representing the lanes and directions of the traffic, with pedestrians crossing path as well. This is what we call the road network. Then the traffic manager will take care of the carriages flow in the whole city, making sure there's no traffic jam, unless there's a gameplay region, of course. The traffic manager will also manage the interaction between the moving carriages and the pedestrians. For example, when there are enough pedestrians about to cross a street, a virtual roadblock will be created, and the traffic manager will stop the traffic to let pedestrians cross the street. Another thing is that for gameplay reason and to give AI a chance, we decided to design the roads larger than normal to give enough space. Here's an in-game screenshot that shows how it looks like. First, let's talk about the anatomy of a carriage. This is the different parts and concepts of a vehicle. We have the horse, which is the tractor. We have the carriage in itself, the joint. Those are the seats where NPCs can sit. Ready? And those are the interaction links. Typically, it's entry and exit positions. Nav mesh patching. So patching is the process of removing shapes from dynamic objects from the nav mesh. We are creating holes, actually. But when we are recomputing the triangle's layout, since we have a horse, joint, and carriage, it will generate weird and concave shapes. And by having those kind of weird shapes, some valid paths will be completely blocked and invalidated. This process is heavy on the CPU, so we decided to cap one patch process per frame, giving priority to the vehicles that were closest to the player. This is a very simple use case where the horse and the carriage are in a straight line, and we can see how it looks like. So the green part, the green area is the nav mesh per se. On top of that, we'll use what we call whiskers links to connect dynamic to static objects. Dynamic to static nav meshes. They are dynamically created during the patching process. It creates some jump links for NPCs. And by doing that, we are improving coverage and we provide more navigations option to the NPCs. That process is not flawless because, we know we are adding more options for the NPCs, but we know that we are not totally covering the area. But, in our game, it was really good enough. Here's another really simple example whisker links. So you can see that there's a nav the top of the carriage is a small nav mesh, and there are links on both sides and on the back of the carriage. Here's a real life in-game that shows how nav mesh patching and whisker links creation will look in the game world. So the pink and orange arrows are different jump options, jump transition option for the NPCs. You can see by the position of the horses from their carriages, the weird shapes that it is creating. And you can see, like in the middle, there's some really odd shape nav mesh. This is the challenge for the steering engine. So let's see how we did that. We had to rework the steering because typically in Assassin's Creed, the avoidance was radius-based. But with carriages, radius-based avoidance produces very anchored paths with huge dead zones. It's pretty obvious. The dead zone, if we use a radius-based avoidance, the dead zone is going to be inside the red circle. And it makes no sense, if the NPC can't navigate on both sides of the carriages, it will just won't work at all. So given that the nav mesh patching process results in weird and concave shapes, we had to implement new steering methods, and it's all depending on the start and destination positions of the NPCs. That method is called convex hull steering. Let's go back to the game world example that we saw earlier, giving that horse joint carriage shape in blue. We're going to use it for the example. So construction of the convex hull. First, we need to build the hull by starting with a simplified shape of the horse and carriage. We will use the rigid body extents. Then, we'll iterate on the edges of the outline and test for intersection with the next shape. When there's a collision, we'll switch to the other shape and continue the process up to a complete loop. This will give us the contour. Now from the contour, we'll iterate on the edges, going clockwise to clear out all the convex shapes. When there's a potential convex shape, we'll just go backward and continue to trace. So the blue outline, this is the hull. First part of the steering algorithms is outside. This is the most common use case where both start and destination's position are outside the hull. For the first use case, it's quite obvious. We'll just go straight line since there's no obstruction. There we go. For that example, we'll first clear the edge, then go straight to the destination. Outside, inside now. This case will happen when the NPC wants to interact with the vehicle. First, we'll use outside steering algorithm to clear the contour. And then when there's no obstruction left, we'll just go straight to destination. Inside, the other way around. So this one will happen when a NPC gets off a vehicle. First, we'll use the shortest path possible to reach the extent of the hull. Then we'll clear the edge and walk straight into the destination. So by using those three use case algorithms, we are able to cover all our use cases for NPC steering. So let's move to decision-making system in that dynamic world. But before we, I just briefly talk about the loading bubble. So for performance's reason, the NPC's lifetime is player-centric. That means that the NPCs that are far from the player are actually fake NPCs with very limited AI, graphics, and animations. Think level of detail. This has been working like that like for years in Assassin's Creed, but since we added dynamic vehicles, we have a really challenging use case. For example, the case where the NPCs are chasing the player. The player will probably like get on a vehicle to run away, but by running away in that vehicle, it will move much faster. So while the while the player is running away, the NPCs will try to get their own vehicle to chase him. But as the player is moving quite fast, the NPCs will be unloaded. Then you have a major exploits, and we don't like exploits in video games. So what we'll do is that we'll use virtual NPCs and virtual vehicles. We have, as we saw earlier, 6 NPC slots per vehicle. So we will group NPCs to minimize vehicles quantity when they are virtualized. For obvious gameplay reasons, we need to take faction into account when we are grouping them. We will keep very simple persistent data, the health, the visuals, and the target of the vehicles. That's it. And for gameplay reasons, virtual vehicles must be displayed on the minimap, so the player always know who is chasing him. Even when virtualized, the vehicles still need to have minimal behaviors. So we have a simple chase, a simple search when NPCs lost the player and are looking for him, and simple follow for the player's allies. So in short, virtualized vehicles don't have their own AI anymore. They're managed by the traffic manager using the road network. So de-virtualizing. It's based on player proximity, and the respawning process is managed by the traffic manager by creating a hole in the traffic or by just replacing a vehicle that is out of the player's field of view. We cheat a lot with the camera's field of view. And the player and all NPCs must be respawned at the same time to avoid popping. So that covered the AI improvements that we did on AC Syndicates. Now let's talk about a couple of best practices in gaming. Doors, one of my favorite topics. There's a web link. You should really read that blog post about doors. It's quite hilarious, but it is very true. Doors need rules and clear rules. For example, opening and closing doors, and is the player and the NPCs can interact with the door? If then, what happens when a player and an NPC tries to open the same door at the same time? Who has priority? How does it work? More technical stuff. Can the nav mesh or pathfinding be obstructed by an open door? So if there's an NPC stuck by an open door, it will just like look stupid and could even create like walkthrough breaks in some missions. Exploits, queuing, like if there are multiple NPCs waiting for the same door, they look dumb and the player can just shoot them or kill them one by one, and there you go, easy fix. We also need to think about nav mesh erosion. Basically, what is nav mesh erosion is that when the nav meshes are created, they're not perfectly tightly fit with the world geometry. So there's always some sort of a buffer all around the world. So we always need to make sure that the NPCs have enough space to pathfind and steer through doors. Same rule applies for like narrow corridors, for example. So in my opinion, confined spaces plus door is really the AI programmer's worst nightmare. Honestly, think about doors, and if you can, avoid them. Or if you find really good solutions, send me an email. I'm always interested to discuss about doors. Next topic is about heights, rooftops, and ladders. It's a super important topic because there's a dependency with the game world design. In AAA games or games developed by big teams, You always need to make sure that the world, building the world and world design is aligned with the game design and the different systems and features of the game. So a thing to tackle really early is that where NPCs can go in that game world. And that's a vital part, because building worlds is expensive, and you don't want to have to scrap some good work to remake some parts because we need to fix some NPCs pathfinding. As I was saying, it's crucial that world design is aligned with game design. Make sure that NPCs can have as many climbing routes as possible, so they don't bottleneck on ladders and queue like stupids. Same rule than doors. Another great topic within that topic is staircases. If you have melee combat and staircases, it's complex. Make sure they are large enough and not too steep. You might even have to have simpler fight movesets, so it makes sense and it looks good in staircases. If NPCs can jump up on higher platforms, make sure there are many routes available again to avoid the same queuing problem. And if you have rooftops and platforms, make sure they are large enough to facilitate NPCs navigation and double, and it was a triple validated nav mesh. A tiny nav mesh will result in NPCs falling down. We know why, but the player's perspective will be that they fall down for no reason, and that there's a poor AI in the game. Here's one of my favorite examples to illustrate queuing. In Shadow of Mordor, the player can kite NPCs to a ladder and just then climb up and kill them one by one. And let's be honest, for the record, you can also do that in Assassin's Creed in some locations, but I will let the viewers find those locations. Better looking NPCs. That's quite a general topic, but it's still very important. Why? Because it improves the player's general perception of AI. And you'll hear that expression quite often, the perception of AI. You don't want an NPC's movement and behavior feeling more like you don't want them to feel robotic. You want them to feel natural. You don't want a player to feel the sequence of actions. You don't want a player to feel like the state machine being executed on the NPCs. I was talking about general perception of AI. The point is, you can have the best decision-making and pathfinding algorithms in the modern world, but if your NPCs look bad, this is what the player will remember. For him, it's going to be, oh, the AI is poor. So what can you do to improve that? On navigation, you can smooth the planet turns, so the NPCs are not like turning like robots. You can smooth the obstacles avoidance by adding a bit of noise and randomness. You can make sure that the NPCs will face the destination orientation when they reach it, not like after. It's better to change the orientation of the NPCs while he's walking upon destination than make him turn afterwards. You can make sure that there's as much coverage as possible for the Pathfinder. And you can also induce intents into pathfinding with adding lookouts, for example. Another way to improve the look of your NPCs is to have animation and body layering. Basically having your action coupled in different layers. You have full body layers, for example, triggering an alarm, reacting to a threat, exploding and tripping on a trip mine, some sort of like complete actions. Then you have lower body actions, walking, running, everything that the legs are doing. On the opposite, you have the upper body actions, pointing at the player, uncheating a weapon, poking into a hide spot, etc. Focus actions, lookouts, and you can have like voiceovers. Voiceovers, they provide an excellent sign and feedbacks at really low cost. We'll talk about VOs after. Here's a very simple example to illustrate layering. So instead of sequencing the actions one by one, that, and doing that feels robotic and state machine-ish. Just layer them to be triggered simultaneously. When you know or you can predict the length of your action. Let's say instead of reaching the hide spot, then uncheating the weapon, then searching that hide spot, let's just start uncheating the weapon while the NPCs is walking, and just like starting search before reaching destination. It's not rocket science, but it really improves the way the NPCs are moving. I was talking about voiceovers and animations. By just quote unquote adding animations and VOs, you can produce a lot of variety and flavor to improve and help the perception of the AI at very low cost and low risk. It is magic. Do it. It's real magic. And since it's magic, you don't even have to change the gameplay and design rules. It will just give a good feedback for the players. Two of my favorite examples, in the Batman Arkham games, when Batman jumps into a setup and NPCs are seeing him, they became nervous, and nervous NPC would just like use different walk cycle, different animation, play VOs here and there. It's a great way to set the mood in a setup. Also in Metal Gear Solid games, the NPCs will talk to each other. It's quite stupid. They're talking in the virtual radio, just in the speakers or the headphones of the player. Like the guard in that watchtower that will tell his friend that on the ground that look in a specific direction, look at that spot, maybe he's there. So it without a huge cost, it will just give a sense of group organization and coordination. Then more technical stuff, testing and coverage. Don't think everything will go as planned. We know this. Shit will hit the fan, and you will have to find a quote-unquote creative solutions, which are called ugly hacks. Every game has hacks. But, as an AI programmer, you want to avoid having like a small change breaking something else or something bigger. And since you want to avoid that, you want to, having to retest the whole AI every time you're making such a change is it's painful. If you have the time and luxury to implement it, try to have as much automated testing as possible, like unit test, gens, auto coverage, etc. And let's be serious and honest. Implementing automation must be done while the rest is being implemented. Because if you plan to do this at the end, you will just not do it. And it's fine if you don't have the time and luxury to do that. But we need to assume that if we are going with automated testing, we need to do it while we are developing the systems. Releases. We're smart. We are developing AI. We're the future. It's amazing. We might have the tendency to tell our stakeholders, we will develop the system. It's going to be perfect. Come see me back in 2 years. It's going to be amazing. That won't work. Implementing the systems, then the use cases is a very, very bad idea. We also need to keep the context in mind and to test. Showing results, even the smallest, as soon as and often as possible is the good way to work. And for those working in bigger games, be smart about the production phases. Conception at the beginning, a small team, it's there to prototype and try new stuff. It's all about risk assessments and proof of concepts. Allow yourself to fail. Fail is an option, because by failing, you will, set the technical boundaries of your system. Then as you move to pre-production, it's all about getting ready for assets, missions, and systemic gameplay production. Implementing the AI from a programming perspective is just one slice of the cake. There are others as well that will depend on what you're doing. Missions, character, etc., animation, etc. Make sure you have all your core systems ready before those teams are getting in the project. And in the perfect world, you will use production for iteration. yes, it's the perfect world. There are things that aren't on plan, and you would realize stuff while moving on. But let's try to use that as guidelines. Performances. We've been there before. We know that near the end of the project, there's a 100% chance that we will have to reduce the numbers of NPCs in some situation. It will happen. So no matter what your algorithms are, make sure they are optimized and most importantly, scalable. Also, we're smart, we're doing AI, we like complicated stuff, but the complexity of the algorithms regarding number of NPCs, it doesn't have to be complex. So don't hesitate to fake and simplify when needed. You don't need a super complicated AI to manage a massive crowd, where like crowds are basically navigating on a path or fleeing a trap. And as I was saying, conception and pre-production should be used for risk assessment, proof of concept. It's the perfect time to set expectation and ambitions regarding AI. If you are like developing a massive battle system with like thousands and millions of NPCs, and you're doing a test on a world with just a plane without graphics, it will not. Oh, sorry. It will not chip. We need to be realistic and set the boundaries. So to wrap up, as I was saying, it's all about the perception of the AI. That's cruel, but it's the truth. AI realization matters. Nobody likes uncanny valleys and NPCs acting like robots, of course, unless they are actual robots. So the truth is, the AI perception from the player will be as good or as bad as its weakest part. So be smart where you invest your time and make sure it's balanced within the different systems and layers. And don't forget animation. So that's it. Thank you very much. It's been a real pleasure to share all this with you. Don't hesitate to contact me 24/7, summer, Christmas, night. It's okay. I really love to talk about everything related to AI. So let's keep in touch, and thanks a lot. I'm back on the webcam. So I will read the question, read them loud, and just answer. So let me scroll up. Okay. Simlik asks, how do you realistically deal with the situation where a player or an AI runs behind an object? The key here is not running or not behind an object, it's just not being stuck. So if there's you have a room with pillars, for example, and if you can avoid the NPCs to go too close to those pillars, you can just like tweak your steering algorithms to make sure that the NPCs can start to avoid them earlier. But make sure they're not like going too far from those objects, because it would just look weird. Also, we need to in games you need to have fallbacks, even if it looks like crap. For example, if you have mission essential NPCs that needs to reach a certain position, when they are really stuck, because in a systemic game you don't know where obstacles can be, vehicles, or if you have world destruction, for example. So at some points you will have to teleport NPCs. Who can be a bit clever or more, teleport them if the player is not looking in that direction, but you don't have control on where the player is looking. So we might always have this camera looking at the NPC's stock NPC. So yeah, sometimes it's bad, but we need to teleport them. Make sure you teleport them inside the nav mesh. Another question from Simnik. I remember hearing that when hunting, foxes would avoid people by running behind trees and disappear from sight that way. if you teleport NPCs, they will disappear. You know, it's a fallback. We need to assume that. I think it's okay to re-teleport them in front of the player, because at least the player will see that they're still there. And you know, if you have decision making involved, for example, if NPCs were having a line of sight on the player and you were chasing them, you know, you don't want to create an exploit. So if they're teleported, make sure they still have a line of sight, or at least they are able to reach the last known position. Another question from Joseph Azem. When the player is not looking, are non-essential NPCs AIs in the scene, like a marketplace, active? Okay. No. As I was saying, let's say you're managing a crowd. So they're a huge, massive crowd. The point is more density than AI. You know, you want the world or the marketplace to feel full, not empty. So you know, in Assassin's Creed we have like many level of details. For example, when the crowd are quite far from the player, we just need to have like a sense of density. So it's just like a blob of almost zombies. When they're close to the player, they are disposable. So we can just replace them and swap body parts to so the player feels that they are different people. We don't mind what is not in the camera. What's important is what the player sees. So what's in the camera field of view. Another question from Joseph. AI polling, yes. AI polling is just like having and it's depending on the LODs. Let's say we have really high-end NPCs and we are allowed to have 800 of high-end NPCs, so we will just create a pool. And whenever a mission, cinematic, fight setup needs high-end NPC, they would just like ask the pool, hey, give me a high-end NPCs. And of course, we need to make sure that it is balanced within the game, and then that there are not too many requests to have high-end NPCs. Same thing with crowd. So we'll just like reuse the same from a pool. Another question from Joseph. It is spawn AI in radius and put in the player's field of view. It's always the same AI, just different meshes. Yes. As I was saying, we have different level of details. What matters here is with non-essential NPCs, crowd basically is density. Does the engine do any automatic work, or do you need to implement those manually for each new type of NPCs? We have a system, we have managers and templates and stuff, so it's basically just automatically done by a very clever and futuristic game engine. A question from Joseph again. Can I create a crowd using a particle effect for far away crowds? Yes, you can, because it's mainly displaying graphics and density. The thing you need to take into account is, since you are using particle effects, it will be driven by the rendering code. So in Assassin's Creed, all the NPCs has to be aware of each other, not on an individual basis, but at least conceptually speaking. And more importantly, if the player can interact with any high-end NPCs or like dummy crowd, if there can be an interaction with the players, it needs to be taken into account. So if your faraway crowd is driven by the rendering code, they will need to talk with the AI or having some sort of awareness of the player and the NPCs. Another question from Joseph. How many AIs were active at all time in ACs? Again, it's not about how many AIs, we can render thousands of NPCs. It's more about managing the level of details more than how many AI. How do you know how much the player can see? We don't know. That's the challenge. And there are two things we can control to minimize, not minimize, but control what the player can see is first the drawing distance. The more far we draw, the more the player can see. So if we reduce the drawing distance and add some sort of fog, we can limit the distance, and also the topology of the world. If you have really long, straight line streets where the player can see far, far away, but if you have like a medieval city or more organic with the tiny and narrow streets, then you are limiting the distance, and you can render more NPCs close to the player. More questions? What's the best thing about working on a AAA game? Just working in games, it's awesome. It's amazing. When you're in an indie, small teams, you have that sense of control where you have not a lot of people, so they are a lot involved in a lot of things, and they have their opinions on a lot of things. That's an amazing part of working in a small team. On a AAA game, big teams, production value, cinematics, kick-ass animations, is you need to accept that you're not good at everything. I've been working in AI for most of my career, and I suck at art and effects and stuff. And my role is to be an AI programmer, BI, being in the AI team. But what I love about that is, when everything, and on Assassin's Creed, we are different studios working on a huge game. So at one point, all the pieces of the puzzle are coming together, and you get to work on the morning, and then you realize that the lighting team has added lighting on the part of the world, and it's amazing. It looks very good, and you see the new cinematics, new stuff, and you're like, wow, you're kind of discovering new cool things about your own game, which is what I love, basically in AAA games, and the whole production value as well. And last questions. As lead studio on the Assassin's Creed Syndicate, how does Ubisoft Montreal manage different teams to work effectively together? I'm not sure to understand the question, but I'm working at Ubisoft Quebec, and Assassin's Creed Syndicate Quebec was the lead studio. So it was the first time we were lead on an AC game. So how do we manage the different teams to work effectively together? It's a process that we improved over the years. We had the chance to start working like that on the previous generation of consoles, where the game were a little less complex than now. So it's all about trust. You need to, and expertise. When another studio, let's say the NEC studio in France, are responsible for a part of the game, a part of the world, they will be super enthusiastic, and they will be fully committed to that part. And every studios are trusting the other studios, and we are working towards the same goal. And more. No, it's okay. You meant Quebec, of course. It's fine. On the logistic, we have, there's an overhead, of course, but we are assuming that overhead, and we are communicating a lot, live chat, or in the morning. I'm as a lead gameplay programmer in Quebec. I was poking everyone in the studios every day, like, hello, how are you doing? Is everything working fine? Can we do something to help us? Yes, it was taking me some time, but it's my job, you know. And having a couple of people in another studio helping us helps a lot more than the time it takes to me. And at the end of the, you know, at the last summer when we were closing the game, we needed help on AI to, you know, for bug fixing. So we had like 6-7 AI programmers from the Sofia studio in Bulgaria just jumped in the project to help us, and that was really like appreciated. And they help us ship the game, and you know, everyone is part of the team. That's what's cool about that. So this is it. Thanks a lot. It's been a pleasure. And again, poke me by email or Twitter or whatever, smoke signals if you want to talk.